We did it. So, UFOs. No. Oh, I know, Beth. I know. That's our life right now. Did it. So, UFOs. I'm getting an echo from somebody.
Yes, I am too. Somebody's got.
Someone's got the YouTube video on
Beth.
now.
I know. That's our life right now. Did it.
Who is
No,
it?
it's not me because I'm on headphones.
I'm getting it. There it is. That was it.
Me.
So you probably had the YouTube open, so that did it. Yeah,
It's me.
it was
Don't
you.
blame me.
Oh, you didn't have to. We could see that the window was switching to you every time the audio was coming, but
Yeah, I
Look.
did it.
look who's
I am
back.
stalling the show.
Look who's back. Nika's back. How's whatever you've been up to? What have you been doing?
Me?
Yeah.
Oh, I am now feel a little bit pressured to tell everything I did.
Well, you can just keep it to the relevant space-related stuff if you want.
It was actually only space-related stuff.
Okay.
But actually, we have this network in Germany for the new space, and we did a lot of work and did some events to populate new space and the launchers and the projects that we are doing, and we were looking for the funding for this project and some students who would do this project, so this kind of work, and some personal applications.
So you have a little time now, a little spare time, so you came back to us.
No, I am ready to do full gas.
Well, has anyone told you that we go on hiatus in 3 weeks?
Yeah.
Okay, all right, all right.
That's a perfect time to start doing something, because then I have 2 months vacation again.
Yeah, exactly. Your first and last episode. Perfect. All right. Hope you've all had a chance to say hello. I'm going to say hello back. Hello to Alexis Desplond, Andrew Planet, Bob Moeller, Cryptolicious, Daniel McCool, David Dunn, Frank Tippin, Harry Patrick, Ian Farquharon, James Dubbin, Johnny J, Larry Beckham, Larry King, M, Nancy Graziano, Arjone, Ryan Schmitz, Zach Perry, and Zaffin. Beth, get that cat under control. This is outrageous.
He said it was on brand.
It is on brand. It is true.
I have chased him off. He just woke up from nappings.
Yeah.
It's a moment of high.
Yeah, there was some classic shots. I wish we had it fully zoomed in there, because there were some parts where he was just like jaws open. It was like some kind of...
the yawn was great.
Yeah. Yeah, that was perfect. Okay. I believe we do a show, so I'm going to get ready to do this. All right.
UFOs and cats.
You did it. You just started this, Beth. All right. Now I'm going to pause briefly for Nancy's sake for the editing. So hold on a second while we pause. Hello and welcome to the Weekly Space Hangout for Wednesday, June 9th, 2021. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about InSight's clever cleaning method. Finally, new pictures of Ganymede, an inflatable lunar habitat, and possibly more. Joining me this week on my screen, the cat herder in charge, Beth Johnson. Hey, Beth.
Hi, Fraser. It's back, by the way. He really wants up again.
It's fine. You know what? Let the cat control the shot, and I will switch back to the cat whenever I think it's the most hilarious. So you won't see it because I'm the one engineering the show, but just know that if the cat is causing shenanigans, it will be shown to the audience. All right. We've got Dr. Morgan Redberg. Hey, Morgan.
Hey, Fraser, I do not have a cat, but we've got a solar system bonanza this week, so it's still going to be good.
There's going to be some solar system herding. Yeah, absolutely.
Yes, I think we can manage.
Returning after a long hiatus, we've got Nika Klimich. Hey, Nika.
Hi, guys. Hello.
Welcome back. And as we were mentioning just before the show, you came just in time to go on hiatus, so it's the timing is perfect.
That's good.
For people who are like wondering what you've been up to, what have you been doing? Like space related? Yeah, what have you been doing? What have you been up to?
So we were like with our network in Germany for the new space, we were doing some projects, looking for funding, looking for students, and the projects were related to the launchers and launch pads from the sea and launchers from the planes to space, basically.
That's awesome.
That's in short.
That's awesome. Are you an astronaut yet?
Still doing that.
Are you an astronaut yet? Oh, I'm going to move on. Now, before we get to our special guest, our super special guest, I promise this is really exciting. I want to give everybody a reminder to join the Weekly Space Hangout crew. These are the friends, the fans, the executive producers. These are the people who help keep us organized, bring in the cool guests, and sort of keep each other company during the hiatus that I mentioned. And just a reminder, we're going to be going on hiatus with all of our shows in 3 weeks. So I think there's like 3-4 shows. We're going to do 3 more guests, and I think we've got one gangs all here episode right at the very end before we go on hiatus. So if you want to connect with all of your friends during the summertime, go to wshcrew.space and join up. All right, let's get on with this week's special guest. We've got Darian Dixon from NASA. Darian, welcome to the Weekly Space Hangout.
Hi, happy to be here. Thanks for having me. Really excited.
Well, I wouldn't go that far, but who are you, and what do you do?
Yeah, so my name is Darian Dixon. I am a Mars rover operator. Essentially, I am part of the Perseverance rover team working on Mastcam-Z operations.
Oh, that's awesome. Okay, so for people who don't know, then what is Mastcam Zed?
Yeah, so Mastcam-Z, Mastcam-Zed is a pair of stereoscopic zoomable cameras on the head of the rover, essentially. The big tall mast with the big square head and the giant eyes. We are the 2 square eyes kind of at the bottom of that mast there.
Right.
And so Mastcam-Z is one of the rover's main set of color cameras. We're able to take awesome video, high-def panoramas, actually 3D images as well. Because of the stereo position of the eyes, we can actually create awesome 3D images and multispectral images too, looking at Mars in different wavelengths of light than just the visible. So Mastcam-Z is an awesome instrument. Cameras get a whole lot of use and bring down spectacular images of Jezero crater.
So how does the Mastcams differ between the two rovers? Like
so the Mastcam. Oh, go ahead.
Sorry.
Sorry.
Oh, that's what I was going to ask. Yeah, like does it have the same? I know the instruments, even though the chassis is very similar between Perseverance and Curiosity. A lot of the science instruments are vastly different, sort of highly upgraded and improved.
Yep. So Mastcam-Z, kind of the same deal there. It's an improved model of the Mastcams that are on Curiosity that are still operating today. And the biggest difference is the letter Z added on there stands for zoom. And so the Mastcams do not have a zoom component. They're actually fixed zoom length. The left and the right eyes are fixed at different focal lengths. Whereas on Mastcam-Z, we can actually zoom in and out with both cameras to look at things in different zoom levels. And that creates opportunities for a lot more spectacular images, a lot more dynamic images. And we're really excited to be using that on Mars.
There was a great picture that came out. It was about a week ago or so, where it looked like it was an image of Ingenuity taken with Mastcam, and it kind of looked like it was being seen through binoculars because it had that really high zoom. And I think that people have always been asking us, like, why don't they send video? Why don't they send better camera? Like Perseverance has essentially video, better zoom, better optics. It's such a great photographic platform sent to the red planet.
Mm-hmm. Yeah, no, these are spectacular cameras. It was awesome with the helicopter videos that for a lot of these, with the dual zoom and the dual cameras, we're able to take, a close-up video and a far-away video, and sometimes being able to see the helicopter up close, getting able to see the rotor spin in high definition, but also see it further field, seeing it fly through the air better, seeing the terrain around it as it flew. And it's just amazing to be able to do. And I sometimes get questions also about, why don't we send better cameras up there? But you look at the things that come down, and I think they're pretty amazing. We get to take these fantastic images of Mars. The zoom capability is really awesome. Our zoom distance is actually much more potent than you would see on your standard consumer camera.
Yeah.
Able to zoom in and out a lot farther. So things like that, we're able to do spectacular things on Mars, and it's very exciting.
Well, for people who maybe do have, say, a DSLR, how would what Mastcam-Z is? Sorry, I'm Canadian, so how would the Mastcam instrument compare? Like, I'm sort of imagining, say you've got a zoom lens, you've got a whatever its millimeters are, you've got a certain size CCD, megapixels, etc. How does Mastcam compare to that?
Yeah, it's kind of hard to compare, just because there are so many different types of consumer cameras.
Sure.
I typically compare it to, say, an iPhone or something, the typical kind of camera that people carry around in their pockets every day. There are some DSLR cameras that might be able to, do far better zoom or better resolution, but again, they aren't doing those on Mars. They aren't doing those in an environment where we can see temperatures as low as minus 40 degrees Celsius and that sort of thing. So in that way, the performance is, unbelievable. A lot of our cameras, if we took them up there, they would completely crap out. You're not taking a Nikon to Mars, that sort of thing. But with something like an iPhone, we're seeing a focal length of about 26 to 52 millimeters, right, I think, for the iPhone XS. And for Mastcam-Z, we're getting 26 to 110 millimeters. Nice. So pretty impressive zoom there compared to the thing that most people carry around in their pockets. And I like to say that when people are like, well, why can't I take my iPhone to Mars? And it's like, well, first it'll break, and then second there's that. So
you kill the battery. Yeah. So then, I mean, your background is in planetary geology. And so as a geologist, being able to look around at this landscape, what are you looking for?
Yeah, so what we're looking for, it's a variety of things. And a lot of it comes from the scientists. They're kind of the keen eyes that guide our hand that's controlling the camera. It's letting us know what to look for. But any interesting geologies, essentially, and there's a variety of different voices and different specialties on the mission that want different things. Some people want to look at volcanics because they're really interested in the volcanic history. Some people want to look at sediments because they're really interested in aqueous activity, really interested in water, really interested in anything that might hold signs of past life. And so there's kind of, now with this mission just starting, I think we're kind of in the phase where we're looking for anything exciting, we're looking for anything interesting for us to zero in on. With this next science campaign, this first science campaign starting up, we're going to be driving up to a nice little overlook and surveying out in Jezero Crater and kind of getting our first lay of the land of our new home. And so for all the geologists, we're looking for exciting things that will be more interesting to drive up on and analyze.
Yeah, and I think that's, in fact, we were just talking about this beforehand. Morgan was suggesting this just later on that we were going to talk about this, but I think we can shift this topic earlier on, which is that up until this point, Perseverance has been really testing itself out, making sure that everything's functioning properly. It's been throwing helicopters out onto the Martian surface, but it has a job to do. So, the beginning of its science campaign, what are sort of the main objectives for this first phase?
Yeah, so for this first phase, one of the main things we want to do is get to this overlook, drive there, and really survey the land, really get a sense of what's out before us. As far as more specific objectives, I'm not entirely sure. I pay a lot more attention to kind of the downlink and telemetry and computing side of things. But there is that main goal of getting out and taking some really good reconnaissance imagery and Mastcam-Z will heavily be involved. The nav cams will be heavily involved, and getting our sense of, what's our roadmap to Perseverance's big objective. We're here to look for signs of past life, look for any potential rocks that would have a good candidacy for having preserved any signs of past life. And so we're getting the start on that. We are driving up to a hill and saying, this is our playground. Let's see what we're going to see. Let's find the good spots.
In the selection of Jezero Crater, I know that NASA put a lot of work into sort of looking at all the different spots, and Jezero Crater just jumps out as the perfect spot to send a rover. Yeah. There couldn't be a place that's more obvious that there was past water acting for long periods of time in this region. So is the reality now that you're inside and sort of driving around inside this region, are you really starting to feel this reality compared to the hope?
Yeah, it definitely. It's really exciting, especially with you mentioning the landing site selection process. In grad school, I got to go to the landing site conferences and listen to all the debates, be a part of the voting for the landing site. And Jezero Crater was one of my top selections every time in every round of voting we did. Really excited about Jezero. It's spectacular. When you look at the orbital imagery, it's one of those places that makes you go, wow. You see that really well-defined, well-preserved river delta. You see the ancient river channels coming into this crater. And this is not a small crater. This thing is, 28 miles wide, and they think it held a body of water about as large as Lake Tahoe. So we're talking about a massive aquatic environment that we couldn't be more excited to explore. And looking out, in the land and seeing parts of the delta distally, seeing parts of the crater rim distally, we really get the sense that we are somewhere spectacular, and we can't wait to explore it.
We've been really happy with all of the work that's coming back from Curiosity as well. So, all eyes are on Perseverance, but Curiosity is still going perfectly strong. So what's your role with that rover?
Yeah, so I am primarily working on Perseverance these days, pivoted from doing a lot of work on Curiosity. I used to be involved with Mastcam and Molly and Marty, but pretty much only on Perseverance these days. But Curiosity is still going strong, still operating, still carrying out its own mission, exploring Gale Crater, and there's still spectacular things to see there. We recently got to a unit that from orbit was identified to be rich in sulfate minerals, which have a lot of implications for past aquatic environments and potential preservation of biosignatures. So people were really happy to get there after all those years. It finally got there. So there's still amazing things happening with Curiosity. We're taking pictures of spectacular clouds. I'm sure you've seen that recently.
Yeah. And there was a great rock that had been released from Curiosity that I really liked, that we saw a picture of. I know it's kind of nerdy, but now obviously you don't have a role specifically in Ingenuity as opposed, beyond just helping take pictures of it. But what role, now that we've seen, it's on to its 7th flight, and again, as a geologist, what role do you see some kind of aerial platform bringing to the table in terms of geology and the kind of larger search that NASA's doing?
I think it's amazing. It's really, really cool reconnaissance to be able to do. I know a lot of geologists that work in the field now, one thing that's becoming really prevalent are drones. People take drones out into the field because sometimes when you're out in the field, out in the forest, and you're looking for a particular outcrop or looking for a particular spot, granted, we don't have trees on Mars, but it's really hard to see that through the trees. And it's kind of a similar environment on Mars, where from our vantage point down on the ground, even though the rover is very tall and can see very far, there might be things we miss. There might be things that don't look as interesting from the angles we get to see them from on the ground. So being able to fly over things and take imagery that way and scout areas that way is really awesome. And it's a really cool tool to have. I love the kind of like hero sidekick dynamic exploring Mars that Perseverance and Ingenuity are going to have.
It seems really kind of surprising to me how quickly this technology of drones was able to make its way to Mars, that like it's kind of shocking and surprising. And now it feels like there will always be a helicopter attached to every single mission that ever goes to Mars from this point forward. Like, it just seems so useful to map out the terrain. It's kind of incredible. So where, again, as a planetary geologist, you studied all the places in the solar system, not just Mars. What's a landscape that you would love to be able to get a good close look at that maybe we haven't seen so far?
Yeah, I think definitely Europa, even though we have plenty of imagery of Europa. But I think Europa is such a fascinating and unique body in the solar system, with all the potential for the under the crust ocean, and the implications of there being life down there, and all the dynamic shifting of the ice on the surface. I think Europa could be a really awesome place to see closer images of. I hope that that's something in the cards for Juno and Juno Cam. I don't really know at all, but it would be awesome. Seeing the recent imagery of Ganymede gets you really excited. And also Titan. Titan is something else that I'm very excited about, which we don't get to see the surface of much because of that very thick atmosphere. But, fingers crossed that everything goes fantastic with the future Dragonfly mission. And like you said, we'll be flying a lot of things on other places. I think Ingenuity is such an awesome lead up to what the potential Dragonfly mission will be. And Titan is another cool place that I think would be really exciting to get a closer look at.
It is really kind of interesting. Like, when you think about Europa, is it smooth like an ice rink, or is it like jagged and covered in those penitentes? Like, we don't even know what kind of hardware could even handle that kind of terrain, whether it have to be some weird, ice scaling robot or something that could skate around. It's like, we still just don't even have enough information. So we really need more data to even know how to
more imagery for sure.
Yeah, absolutely. And I totally agree. The images, we're going to be talking about Ganymede later on in this episode, but to think there's been so long since we've seen any images out of Ganymede is kind of amazing. So what do the next couple of months look like then for you and for the missions that you're involved in?
Yeah, next couple of months for Perseverance, I think fast and furious exploration is what it's going to look like. I think we got through this phase that you mentioned here, working on the helicopter, and this phase where a lot of the things we were doing were checkouts, making sure everything's working, making sure everything's healthy. And now to be in this phase where it's kind of letting the scientists loose. I think they've been chomping at the bit a little bit to really get out here and do their science and check out the geology more than we presently have. We've done some things, but much more than we presently have. I think they're really, really excited. I saw a GIF online of someone, I don't know if they were at like a dog kennel or what, but they opened a gate and all these golden retrievers just came running out the gate. And I feel like that's the scientist right now, just ready to get out there and explore Jezero Crater. So that's what the next few months will look like. It's just,
that's awesome.
Just nonstop exploration.
Well, if people want to follow the work that you're doing and the images that are coming back from the rovers, where should they go?
Yeah, so if they want to follow, all the imagery gets posted on, there's a public images site for Perseverance. The Mastcam-Z team, we have our own public website run by ASU. It's an awesome website. Definitely a lot of things get posted there. I have my own Instagram, if I can plug that.
Yeah.
People can definitely follow. It's at red_planet_green thumbs. The green thumbs part is because I garden a lot.
Oh, awesome.
And a lot is an understatement, probably too much. But
I didn't even know I'm a huge gardener. We should have just had that as the conversation instead of all this Mars stuff. But sure.
I could talk about my banana tree for like 3 days, so we should. But yeah, you can follow me there. I post a lot about Mars and sprinkled in with plants and my dog. But as the mission goes on and as we explore things and make new discoveries, I'll definitely be posting there as well.
Well, awesome. Well, I'm going to congratulate you in advance for all the amazing discoveries that are going to be happening from Perseverance now that the helicopter babysitting duty is mostly over. It's time to get to work. But thank you so much for taking the time to chat with us today and join us here on the Weekly Space Hangout. Good luck, Darian, with everything you guys are doing, and keep us posted when you find life on Mars.
Yeah, I'll let you know if that happens.
Awesome. All right. Thanks a lot.
Yeah, thank you for having me. Take care.
All right, let's get on with the news section that we talked about. And Morgan, I want to go straight into this conversation about Ganymede because I am so excited.
Yeah, this was really, really cool. So back on Monday, all the way back on Monday, Juno flew past Ganymede at a distance of about 1,000 kilometers. And that's quite close considering that Ganymede's radius is several thousand kilometers. So really quite close to the planet here. And it's the closest, in fact, really the only flyby of Ganymede that we've had since the demise of Galileo in 2003. Galileo, the spacecraft, of course, the man had met his demise much earlier than that. And I think the last real Galileo flyby of Ganymede was in 2000. So we're talking 2 decades worth of time, and obviously a lot of improvement in technology. And it's not surprising that this is the next real flyby because there haven't been any missions to Jupiter between Galileo and Juno. Both New Horizons and Cassini flew past Jupiter on their way out of the solar system and took some long-range observations of the moons and, of course, the planet. This is our first real chance to look up close, and it's part of Juno's new extended mission. So Juno, since arriving in 2016, spent a number of years in this polar orbit around Jupiter, making observations of the planet and its radiation environment around it. And part of the deal, basically, for extending the mission beyond its initial four years was that Juno also began to make observations of the Galilean satellites. And so this is really just kind of a taste of what's to come as Juno makes flybys of the other Galilean satellites as well. And Ganymede is, it's the biggest moon in the solar system. It's bigger than the planet Mercury. And when you put it in that context, it's sort of remarkably understudied and remarkably not well understood. It's the only moon that has its own magnetic field. And so it's embedded in Jupiter's magnetosphere, which is by far the most powerful of any planet in the solar system. And so the interplay of those will be interesting and something that Juno certainly will be investigating because it carries a vastly better array of particle and field instruments than Galileo did. But right now, what we're all oohing and eyeing over are the photographs. Mm-hmm. And it only took a tiny number of pictures because it was zipping by at some ludicrous speed. And you can kind of see the effect of that speed in these early photographs that came back. But what we have seen so far is amazing.
Yeah.
I mean, the surface of Ganymede is just weird. Like, Europa has gotten a lot of attention for having weird surface properties, but Ganymede has a real weird surface on it. And one of the things they're hoping to do, and I'm a little skeptical that this is going to be successful, but they're hoping to compare images from Juno to images of the same region from Galileo and look for any changes. And in particular, they're hoping to find evidence potentially of impacts on the surface. And if they could find those, that would help quantify the rate of impact on the Galilean satellites, which would help us understand the material that's being potentially exchanged between them, as well as absorbed from, say, the asteroid belt or the Trojan asteroids or something like that. But these first pictures have resolutions measured in hundreds of meters per pixel. And so it would take a big impact. We've done this successfully on Mars a number of times using HiRISE, but HiRISE is measured in centimeters per pixel. And so we've seen a number of small, meters to tens of meters craters that have poof appeared on Mars, but it would take a real big whack, I think, to be observable in these Juno cam images.
So when we're looking at these pictures, and I've been sort of displaying the picture for the audience, what are we looking at? Because it kind of looks like the moon, and it kind of looks like Europa. Like it seems to have some of those strange striations like Europa does, like almost like cracks in the ice, and yet it's very gray and has quite a lot of cratering on it. So, and it doesn't have the same kinds of colorations that Callisto does. So what's going on?
Yeah, the origin of these weird discolorations is sort of one of the prime mysteries, I would say, about Ganymede. So the first thing to know is that, like the other outer solar system satellites, the surface of Ganymede is principally made of water ice. So that's one way that it's clearly differentiated from, say, Earth's moon. So even though the colors might look relatively similar, the material that we're talking about here is ice versus rock. And then, I don't know which picture you're looking at, but in a couple of these pictures, I'm scrolling through the Universe Today article written by Nancy Atkinson, you see these sort of weird kind of irregular swaths of dark. And they kind of look like birthmarks on the moon's surface. And to my knowledge, we don't really know what they are. Sort of vaguely, they're probably dirty. But why the dirty is there, and with these sort of really, I mean, to my eye, the patches here look a lot more uneven than what even you see on Europa. And on Europa, the story is kind of, this is material, we call it tholins. Carl Sagan made this up. This is material that is coming out of the volcanoes on Io, being picked up by Jupiter's magnetic field and sort of distributed around the inner satellites of Jupiter, so the Galilean satellites, and falling back down on Europa, which is the next closest satellite to Io. Ganymede, on the other hand, is a decent amount farther away. And so it's a little harder to imagine that story holds up. And even if it does, you would expect to see a pattern. Like the material will be deposited principally on one hemisphere, or principally along the equator, or principally at the poles. You'd have some story for why, but it kind of looks like a kid just sort of smashing finger paint across the surface of the moon, and I don't know if we're really going to get a good answer from these Juno observations. But one of the things that Juno can do much better than Galileo could do is make observations of the surface in wavelengths other than visible light.
Right, they've got the infrared.
And so, Juno is really not a taking pictures mission; it's a measuring all the other radiation, and by radiation we mean light, mission. And so it's been doing a lot of work to understand Jupiter's atmosphere based on the kinds of photons that are being emitted by the molecules in Jupiter's atmosphere. And it may be able to do something similar here to get a better handle on the composition of the surface of Ganymede. And that composition will be a huge addition to our sort of ability to puzzle out what might be going on here.
Yeah, I really, I say this quite a lot. I really feel like Ganymede is the new Europa. It has this water ice surface. It has this subsurface ocean, although it's way deeper, like hundreds of kilometers possibly under the ice. It has this internal magnetosphere. And it has a ton of mass. It's a really interesting place. And the European Space Agency is going to be sending their JUICE mission to primarily Europa. They're going to visit the other planets, but Europa is the main destination for JUICE. But we won't see that for another decade.
Hopefully at the end of the decade. I think it might arrive, or might launch late in the 2020s. And if we kind of pull back to that range, this new campaign by Juno is going to be really important, because it's going to help establish the important science questions on top of what Galileo has already sort of opened up in preparation for what's going to be kind of a blitz at the end of the decade on Jupiter. Of course, not only will we have JUICE from ESA, but we'll also have the Europa Clipper mission, which could be launching as early as 2026
Wow.
for an arrival by the late part of the 2020s. And like JUICE, it's principally going to focus on Europa, but it'll make some observations of these other satellites as well. And it's important to sort of know what to be looking for.
Mm-hmm.
Like, what are the things, the kinds of observations that we can make? Because what we found with a long-lasting mission like, say, Cassini, is it made great observations at the beginning of the mission, but it answered a lot of science questions near the end of the mission because it knew what to look for and where to look. And it wasn't, to begin with, you're kind of just sort of shooting in the dark, trying to see what's there. And every bit of light that Juno can shine on one of these moons will help guide the way for making more efficient use of the limited observation time, especially of the non-Europa satellites. You know, both these missions are going to make just gobs of observations of Europa, but they're only going to have a few flybys of Ganymede and Io and Callisto. And so knowing how to make the best use of those is going to be really important to getting the most bang for our buck out of this once in a generation sort of ability to visit these moons.
And what do you think? Like, you know, the question that I asked Darian, like, if you could get down to the surface of, say, Ganymede, would it be this mountainous ice, would it be ice mountains, or would it be ice rink with mountains, do you think?
Yeah, I think, I mean, you look at the surface and you're going to say that there's a little bit of all of that on the surface. And if we kind of piece the picture together from other icy worlds that we have better observations of. So we've seen, for example, Triton around Neptune through Voyager 2. And it had all this, what they called chaos terrain at the time, which is just this sort of, it looks like you just kind of stirred everything up and then froze it in place. Then we look at New Horizons visiting Pluto, and what do we see? Well, we see some areas like, you know, Sputnik Planitia, where you have these broad, flat plains, and then you have other areas that are just mountain after mountain after mountain after mountain. And I think just as we've learned in places like Pluto, we have to sort of stop viewing these moons like Star Trek planets, where the whole planet is one thing.
Right.
These moon, I mean, this is a planet or a moon that's larger than planets. It's going to have a dramatic variety of terrain. And the question is, which pieces of those terrain are we going to be able to study? And which pieces of those are actually going to prove most interesting long-term in the context of the broader solar system?
Yeah.
And of course, we're all interested in the ocean and any potential connection to liquid water. But there's only going to be so much that either of these missions really can do to probe the ocean. There's a lot more fertile ground to probe on the surface if we can just figure out which pieces we want to look at.
Yeah, totally. Very cool. Thanks, Morgan. All right, Beth, also in planetary news.
Also in planetary news, the InSight lander is once again proving to be that little lander that could. It keeps facing challenges, and the team behind it just keeps coming up with wild and ingenious ways to fix things.
There's been one insurmountable challenge.
Well, one insurmountable, but they found some interesting ways to try and get over that. So the shovel on this lander has been far more valuable of a tool than I think anybody realized it was going to be. Yeah. So Mars is getting ready to approach aphelion. So it's going to be its furthest point from the sun, which means it's going to not get as much sunlight, which is a problem when you're running on solar power. And additionally, Mars is very dusty. So these solar panels have been collecting dust the duration of the mission. And in order to sort of reserve power on the lander, they wanted to find a way to boost how much sunlight they're actually taking in. And they decided to use this little shovel once again to basically pour dirt from the surface of Mars onto the solar panels in the hopes that the way that would bounce and get blown off by the wind would wipe some of the dust off with it. And it worked.
What?
So the lander actually has gained 30 watt hours of energy per Martian day from just this one attempt at it. And they're going to do it again.
Hold on. So they dumped dirt on their solar panels, and what that did was cleaned off their solar panels.
Yes. So they did it at a time when there was Martian wind is a relative term here, but when it was the highest level of Martian wind that they knew was coming, they dumped it at that point. And what happens is these big particles, they saltate. So they hit and bounce, and they carry other stuff off with it. So if you've ever seen like a rock like hit the bottom of a riverbed, and then it like digs smaller rocks out and they get pushed up into the current, right? So it's the same thing with the bigger pieces of dust going onto the solar panels. So they drop the big pieces of dust on it. The wind picks it up, bangs it against the solar panels, scrapes off some of the smaller particles, and carries those off into the wind. And yeah, it worked.
The key piece here is that the really small Martian regolith, the really small bits of dust, the physics of them are dominated by electrostatics. And so static electricity between the solar panel and the dust is stronger than the force of Mars's thin atmosphere trying to blow against them. Larger bits of gravel and clumps of regolith are too big to be affected by electrostatics. And so they are dominated by the wind. But when a big piece, as Beth said, hits a little piece, that physical motion can overcome the electrostatics in a way that the wind itself just doesn't have enough momentum to be able to do. But this is just like a crazy, like bananas idea. It's just nuts that they thought that this would work, and they did it because they watched. They were burying other parts of the spacecraft for insulation, and this is like observation matters in science. They noticed as they took photographs of this process happening that dust was being uplifted, and somebody like put their thinking cap on and said, golly, I wonder. And here we are.
So they were burying the cabling for the seismometer, because even the Martian wind is enough to sort of you can sense it on the seismometer. It's sensitive enough. So what they're doing is they're dumping dirt onto the dome of the seismometer, same shovel, and trying to get it down to fall down onto the cabling, so that the cabling is insulated some more from the wind, so they stop having that as a background noise.
Oh, and so they were dumping this regolith onto the dome of the seismometer, and watching as the dirt was coming down, it was kicking away bits of the dust that was covering.
You can actually kind of see it like scraped a little bit clean from the dirt falling down. Right. So somebody said, "Hey, let's try this with the solar panels."
But are the solar panels flat? Are they tilted toward, like, are they at a slope that it'll sort of fall down off of?
Right. So the seismometer, it's domed. So obviously they're going to fall. The solar panels are not at that same steep angle. So that's why they're depending on the saltation effect rather than just the gravity force of pulling the dust down. This is more of we have to break it off from that electrostatic force. Yeah. And so that's why they do it when the wind is highest. And they're going to, I think, try it again this weekend. And, so that way they can actually have the wind pick up the larger particles, and so those will actually kind of bounce along the solar panels and grab the smaller dust, break them off.
It is kind of funny, like I don't know if you get this as well, but all the time people come up with all these suggestions when they hear about the dust. They're like, why don't they put windshield wipers on them? Why don't they? Mostly windshield wipers, and you can imagine like scraping the regolith across your solar panels. That doesn't sound like a thing you want to do to your solar panels.
And actually, someone asked it on Twitter, and NASA Insight replied, because they were asking, like, why don't you have windshield wipers? And they said, because it's too many points of failure. It's more weight on the craft, and so then now you need more fuel. So honestly, that's the big reason, is you need big windshield wipers, and you now have another mechanical thing that you have to keep track of and not have break.
And that regolith has this electrostatic charge, which probably will connect, will stick in ways that you can't necessarily scrape away. So it is kind
right.
of...
I mean, this is a huge problem they're trying to solve for going back to the moon, because that regolith is so electronically charged. I'm having trouble talking today. That it sticks to everything, including spacesuits, and it's sharp and glassy and can cut everything.
There's when the sun rises on the moon, it sort of changes the temperature, changes the level, and you get this wave of regolith that gets lifted off the surface of the moon and shifted over every day on the moon. You'll get this fresh snow of regolith on everything that you're using. And this stuff is, of course, tiny little pieces of glass. So it's very, very dangerous. So does this mean now that everything needs to have a shovel?
I think so.
Yeah.
I think
a shovel and a helicopter?
It needs a shovel, and we need a helicopter. And I think
helicopter can blow the dust away as well.
There was a great note in the NASA press release about that. Apparently, a ton of people in the public have been writing into NASA and suggesting that they fly the helicopter over InSight to use the rotors to blow off the dust.
Well,
and of course, the only problem with that is that the helicopter is like 3,000 kilometers away, or something. But it's the public has got their thinking cap on about they're one step ahead of you, Fraser.
Yeah, no. And of course, Perseverance is powered by a nuclear battery, so it doesn't need to have its solar panels wiped off. So, yeah, absolutely. It is funny, like just how much the public just is always thinking of solutions. And I think that people, I mean, most of them have already been thought of, but every now and then people in various industries will think of something that nobody's ever thought of. And it's great. I'm sure NASA, to a certain extent, appreciates having all of this sort of mind power across the planet trying to solve these problems. And because it's funny, because like sometimes somebody just has an expertise in some kind of material that is sort of relevant to the situation, and sometimes these solutions do come along. That's awesome. Thanks, Beth. Okay, Nika, what do you got for us?
So I'm going to talk about inflatable habitat on the surface of the moon for Moon Village that ESA proposed. And the detailed concept was presented on the architecture show currently in Europe. And the design was done by ESA in cooperation with MIT and a famous architecture firm that designed many of the world's tallest skyscrapers. And the inspiration for this lunar habitat came from as I mentioned, the vision of the International Moon Village. Is a hypothetical concept of the permanent settlement on the moon, which can be constructed and used by private and public and space and non-space partners. So the design of the habitat. So the idea was taking the inflatable beam module that is currently attached to the International Space Station as the starting point. And the design team, the architecture team, designed a semi-inflatable shell-like structure to offer the highest possible volume to mass ratio. So the beam module, for those who doesn't know, is the Bigelow Expandable Activity Module, which was launched to ISS in 2016, and it is a technology demonstration for inflatable habitat. And it's proven to be successful. So the current ESA habitat that we are talking now has a 4-story high, and it has, as I mentioned, shell-like egg-shaped form. And it has a high floor-to-ceiling space to allow crew members to use the 6 of the gravity on the moon. And the habitat is encased in the protective shells, like a 9 layers of protective shells, which resulted to be not enough, actually. This protective shell will basically will make it resistant to the extreme temperatures we mentioned, the particle and dust mentioned earlier as well, and the solar radiation. So once inflated on the lunar surface, it would be approximately the double size of the original inner volume. And after landing, this habitat would be inflated either by, like locally by astronauts or via rovers teleoperated from the Gateway station flying around the moon. And this habitat would keep around 4 people like safe, alive, and comfortable for up to 300 days at a roll.
Wow.
So the moon habitat blueprint is envisioned for the rim of Shackleton crater, which is near to the south pole of the moon, which receives continuous daylight throughout the lunar year. And the site has a nice view on Earth, and it has access to the water ice deposits. And basically the infrastructure, habitable structure, is intended to, like, for the crew to harness sunlight for energy. So that's the main things that were discussed, so that were designed. And it's like 48 tons, and it was planned to be flying on SLS, but it ended up being too big. So they are thinking about like a Starship, but the connector was designed for the SLS. So it's kind of a possible design, but it's still, as I mentioned earlier, this as a study conducted by ESA showed that it still needs like this kind of layer of regolith to like enable this secure stay for this 300 days for the astronauts due to the radiation. So it was not enough.
So I was sharing the video, and it's so cool. I mean, it just, like, they did such a great job of the base and of showing what this is all going to look like. Like, I think that alone will sell it. But at its simplest version, what would it be? Like, what would be the first iteration that they would send to the moon?
So they were actually having several options because it got too big. They're like let's do it in 2 parts, or let's just do 2 stories, like not the full thing, but like 2 story. And another good thing is also they designed it in a way that you have like 3 entrances on the sides, and you can actually connect several modules together. So you can basically fly 2 of them, 2-story, for example, and then connect them together. And they actually, since they are planning it for the village, like Moon Village, that ESA actually announced as a concept, they are like thinking about like another hubs, not only just like habitat for the living, but also laboratory, power station, and so on and so forth. So they can adapt these habitats for various purposes.
That's really
and
cool.
Connect them together. And it was a nice picture, like how it can be connected and done.
Yeah.
But
very cool.
And it's like different from the ones, because there was a proposal from the like in US, you have like 2 companies like Bigelow, as we mentioned, this beam that is on ISS. So they were proposing something for the moon as well as there was a Sierra Nevada corporation that was proposing exactly the same, like a balloon-like thing. And like this one is basically they are taking this egg, basically, or a shell on the top of a lander, and they land in together. But like for these 2 other in US, it's a little bit different. You somehow have to transport this other shells to the surface of the moon, so you need a crane. By the way, for that one, you need also a crane, you need a rover, you need a gateway, you need actually people being on the moon, like, to finish it. So there's a lot of constraints.
It seems like such a smart idea. Like you've got a rover with a inflatable habitat on top, and then they just find a location and then inflate the top of it, and then you've got a base. So I love the idea. I mean, Bigelow has been doing a lot of great work. As you said, they've got this great attachment to the space station, they've got designs for one that is like has the same internal capacity as the entire International Space Station that could be launched in one rocket. And so imagine some of these that could go to the surface of the moon and build a giant habitat for future lunar astronauts. It feels like we're getting close to having some serious permanent lunar bases, and this seems pretty feasible. I like it a lot. Very cool.
And the bigger one, they also like have one for like a hotel, like a space hotel for actually like, I forgot the number of people, but like hundreds.
Wow.
100?
Yeah.
Something? So like really huge concept, which is nobody proved that it's actually possible. But like, yeah, why not? Why not take the big thing as long as you have a big rocket?
Yeah, we'll start with 4, and then we'll scale up from there. Very cool. Thanks, Nika. Okay, well, we've reached the end of this week's episode of the Weekly Space Hangout. I want to give my co-host a chance to shamelessly self-promote the things they're working on. Nika, you're on my screen. So what are you working on, and where can people find out more?
Yes, so basically, unfortunately, I'm not following my Twitter, so don't go there and don't look there anything because you wouldn't find anything. But I've mentioned the network that I'm working for. It's like Gaia Aerospace Network, and if you Google it, you can find it. We are on LinkedIn. We are we have also YouTube, Instagram, everything. So if you wanna follow it, you can. Please do it. And it's also in English, so it's not only in German, so it's in English, so everybody can read what we are doing.
Awesome. Beth, what are you working on?
We have a few interviews coming up for CosmoQuest on Daily Space this week. Tomorrow we'll be doing an interview about science and art and how they can work together, and also talking to Candy Hansen, who is a PI on Juno Cam. So we're going to talk about some of those Ganymede images. And then next week, I think we're going to talk to David Grinspan and Darby Dyer about the Da Vinci and Veritas missions. So plus, I think I'm doing that for SETI as well at some point. We're trying to get that scheduled. So I'm apparently doing all the interviews.
Perfect. Interviews are fun.
They are. And if you want to keep up on it, you can follow at CosmoQuest X, and you can follow me at Planetary Pan.
Wonderful. Morgan.
Yeah, I've been writing a bunch of things for EOS magazine recently, and a couple of weeks ago I had the great pleasure of being interviewed by our good friend Kimberly Cartier for a series that EOS is doing on non-traditional careers in geosciences. And so I think that interview is going to appear in some sort of audio-based form. I'm not quite sure how it works at the end of the month.
Fantastic. And if people want to follow what you're doing, where should they go?
You check out my website, morganrenberg.com. The Fort Worth Museum of Science and History will be opened on Friday, the 25th of June, and will be open going forward from there. So we've got a bunch of great new things to check out. And so if you're in the North Texas, South Oklahoma region, come swing by and see. We've been working really hard over the last year to make something good come out of the pandemic.
Yeah, I guess you're going to be able to have people return.
Yes, other living, breathing people will be there, and we've got some really wow things that are going to be there. So you're going to want to come check it out. That
is awesome. All right, I'm going to put everybody back up on the screen. Before I go, I guess I should shamelessly self-promote. Of course, Universe Today at all the things. The thing you should definitely follow of mine is my weekly newsletter, my email newsletter that goes out to about 50,000 people every week. I write it by hand. It's gigantic, millions of pictures and links and highlights, and it's really good. So go to universetoday.com/newsletter to check it out. And they come out every Friday. All right. There's everybody on the screen. Here's all of us. All right. Well, hey, thank you, everybody, for joining us this week on the Weekly Space Hangout. The penultimate? I don't know what you call it. What do you call it? I think we have 3 more episodes to the end of the season.
Semi-penultimate?
1, 2. Okay, we've got Ashley Walker next week, Jane Shetstov the week after that, and then the final episode before hiatus. So we have 3 episodes. Trimultimate? Yeah. I'll bet you it's semi-penultimate. That seems right. Anyway, thank you for everybody watching us today. Really appreciate it. Thanks to all of the moderators who kept everything organized in the chat. A special thanks, as always, to Nancy Graziano, who keeps us all organized. And thanks to all my co-hosts and our special guest. And we will see all of you next week. Thanks, everybody. How do I turn this thing off? Wait, I found it. It's over there.
So Fraser, are you